All right, at some point you're going to have to use your measurements or somebody else's measurements to do some calculations. Like maybe you want to, I don't know, you're looking at data of time or distance versus time. Maybe a runner has gone a certain distance in a certain amount of time and you want to calculate that person's speed. Well, that's pretty simple. Speed is distance divided by time, and so you would take a distance measurement and a time measurement and you would divide them and you would get a speed measurement, right? So when you do that division, sometimes the numbers don't work out nicely to give you a really short answer. Sometimes when you do that division, you get a really, really long answer. And if there's anything that I want you to know about using significant figures, is that proper use of significant figures means that you don't report a big long number just because that's what your calculator said. In fact, that's the wrong thing to do, and I probably want to mark your paper with SF or sig figs, meaning that you reported way too many sig figs here, and you need to pay attention to that. Because if you put down a lot of sig figs, that means that you're stating that the accuracy of your measurement is really something that it's not, and you don't want to be fraudulent. You don't want to represent your measurements as something they're not. So you need to be honest about it. In any case, when you're using someone else's numbers for a measurement, let's just, I don't know, let's go back to our measurement of our index card, 12.65. We have some certain rules. So what are significant figures and what are not significant figures? Rule number one is all non-zero digits are significant. Okay, so all these digits are significant. Now say maybe we were measuring something else and we got a measurement like that. Rule number two states that all zeros between non-zero digits are significant. This is a non-zero digit, this is a non-zero digit, and these two zeros in between, they're significant because they're kind of trapped in between these two non-zero numbers. And number three is a rule that once you get a handle on it, I think it's easy for you to understand, but it might take you a little bit to get your head around it. If you go and you Google rules for significant figures on the internet, you're going to get probably more than three. But what I found is that other than this one and this one, all the other rules kind of boil down to the way I've stated my rule number three here. That place holding zeros are not significant. Okay? So let me give you an example of that. If I have a number, and let's just say I took a measurement, or someone else took a measurement, and they just reported it as 100. These two zeros are only holding place to make sure that this digit is in the hundreds column, right? These two zeros are not significant because they're just holding place, right? Likewise, if I have another measurement, maybe I measured something really small, right? These two zeros are only holding place. So this would not be significant, this would not be significant, that would not be significant, that would not be significant because of rule 3. Okay? I think the best thing to do to get a handle on determining how many significant figures there are in a particular measurement is to just get lots of practice. I'm going to do some examples here, and then what I'd like for you to do is to go on to a Khan Academy and practice with sig figs activities that they have there. So I have some examples that should cover all the bases. And what I want you to do is I'll put this up here, and then I want you to stop the video, and then I want you to guess at how many sig figs there are, and then resume the video when I give you the answer. So, 5001.1, how many significant figures is that? Right? The answer is all non-zero digits are significant. So that one's significant, that one's significant, that one's significant, and all zeros between non-zero numbers are significant, that one's significant, and that one's significant. So the answer is there are 5 significant figures here. Here's another one. How many significant figures are in 00.014? The answer is all non-zero digits are significant. So this one's significant and this one's significant. All zeros between non-zero digits are significant. Okay? If there was a non-zero digit here, then these would be significant. These don't look like they're significant because these are placeholding zeros. They are only keeping place for these significant figures. Right? So in this case, there are only 2 significant figures. How many significant figures are in 569? Well, the answer is all these are non-zero, so there is 3 significant figures. This one's a little bit tricky, something we haven't encountered before. How many significant figures are in 6900 point? Here we need to pay close attention to this decimal point, because what the person who took this measurement is indicating is that these zeros are significant. So here's a non-zero number, that's significant. Here's a non-zero number, that's significant. And these 2 are. Okay. If that's confusing, let me write it without the decimal point. In this case, there's only 2 significant figures. In this case, there are 4. The difference is this decimal point. Again, there are only really 3 basic rules, but this third one can be expanded. So if you search the internet and look for rules for significant figures, you might find a longer list. But if you get a handle on my rule number 3 about whether or not the 0 is a placeholder or not, then I think that's all that you really need to remember. Okay.